Greetings, friends, and welcome back to another episode of Augury, Bibliomancy and Chaos. I am Benjamin, the Wizard of Your Dreams, and today I will take you on a journey into the dream research of G. William, call me Bill, Domhoff. And we start with an article here from The Guardian. This will be kind of our narrative source for taking diversions. I am not going to read the introduction. We're going to get straight to the meat. Science is still grappling with the big questions. What does dreaming mean? Why do dreams happen? What do they tell us about our brains? Now, work by neuroscientists and psychologists has led to some intriguing clues about how we enter this alternate reality when we sleep. Some researchers even say that understanding why we dream could be the key to comprehending our own consciousness. For the most part, dreams are still the preserve of the mystic, simply because dream research is not easy to do. There is no way to see what a person is dreaming, and researchers in sleep laboratories normally rely on reports of dreams given to them by volunteers taking part. Often these are selective accounts of what happened. I know, as this person says, that my own dream report after the experiment in Birmingham was only partial. All I could remember were the last moments. And we have here a quote from Bill Domhoff. He says, "I can't cause a dream to happen. It's not easy to manipulate the content." And at this point, we're going to pop over to who is G. William Domhoff. He goes by Bill. He studied dream research with Calvin Hall at the University of Miami, where Domhoff received his PhD in psychology in 1962. Before that, he attended Duke University in North Carolina and Kent State University in Ohio. He has been teaching at the University of California, Santa Cruz since 1965. In 1992, he was promoted to Distinguished Professor of Psychology. In 2007, he received the Constantine Panunzio Distinguished Emeriti Award, which honors the post-retirement contributions of UC faculty. And that is Bill. But here's the thing about this. We're going to take a little bit of a detour before we come back. Number one, because we're following the article, but number two, a lot of things happened between Freud and Jung and now Bill Domhoff, and we got to catch you up on some of that, so some of what this gentleman is doing makes sense. So we'll head back to the article here. There have been lots of studies, he says, in which we tickle you or whisper something in your ear, or we make a sound while you sleep. Dreams are fairly autonomous. They're pretty impervious to that kind of stuff. Even so, the interpretation of dreams has a patchy history. They formed a fundamental part of Sigmund Freud's work and of the development of psychoanalysis at the turn of the 19th century. He argued that dreams were a form of wish fulfillment during sleep arising from our sexual urges. But Freud's argument was entirely subjective. By attempting to work out associations between the dreamer and various elements of the dreams, Freud tried to uncover the latent thoughts he hypothesized must be causing them. Freud said these latent thoughts were always wishful. But fast forward a little bit to 1953, two American researchers discovered a physiological state known as rapid eye movement, or Rem Sleep. This is a paradoxical state. We remain fast asleep, but our brains are as highly aroused and active during normal waking hours. It occurs every 90 minutes during sleep. Experiments in the 1950s showed that 80% of people woken from this state of sleep reported dreams, whereas only 10% of people woken from non-REM sleep said the same. This led to the conclusion that REM sleep was the psychological equivalent of dreaming, and a lot of people believe that today, that REM sleep is the only place dreams happen. Not necessarily true, but largely accurate. And here we've got the two researchers, 1953. This is Eugene Azarinsky and Nathaniel Clayton. Just let you look at them for a second. A couple of funny looking fellas. I like this picture. And here is some of the discussion about that, the discovery of REM sleep. So we have an article from Springer Link. The important part is, to the extent that Kleitman's name is familiar to those who are not sleep researchers, it is due to his co-authorship with Eugene Azarinsky of the paper published in 1953 in the Journal of Science that described their discovery of rapid eye movement. The account of this important discovery has been gleaned from the paper itself and a number of other sources, including Clayton's retrospective description of it in his 1963 book and Azarinsky's recollections published more recently. We're not going to dwell on that too much, but now you know that step of the process, and this was a very significant discovery, a piece of something we needed to know in order to move forward. Back to the article here. By the 1970s, Freud's theory of dreaming was in trouble when Alan Hobson of Harvard Medical School and Robert McCarley laid bare the mechanism behind REM sleep. It is controlled by a switch located in the brainstem called the pons that has very little to do with mental life aside from regulating levels of wakefulness. Hobson had established that REM sleep, and hence dreaming, had no connection with any conscious desires, and that it had nothing to do with wish fulfillment, or so he thought. We're going to take another little detour here. This is Alan Hobson, and he was working with Robert McCarley. And what they came up with in 1977 here is this theory of dreaming. In 1977, two biologists, Hobson and McCarley, came up with what they called the activation synthesis model of dreaming that contested Sigmund Freud's 1900 theory. The activation synthesis theory suggests that dreaming occurred for biological reasons. The dreams were random and had absolutely no actual meaning. In the syllabus here on this page from GCSE Psychology Wikia, it says that you're required to learn the biological theory of dreaming. I'm not going to require you to do that. You can read this article if you wish, and I recommend it. All of these will be, of course, linked in the comments below. And a little bit more on the activation synthesis model. What is really important here? So how does it work? You've got these let me scroll this up here a little bit more. You've got the pons there firing neurons, and then you've got the cerebral cortex synthesizing these signals, trying to interpret them. That was their theory anyway. As suggested by the name, this theory is made up of two parts: activation and synthesis. The activation refers to the random firing of neurons in the brain stem, and the synthesis refers to the interpretation of these random signals into spontaneous thoughts by the cerebral cortex. In other words, during REM sleep, random waves of neurons are sent up from the brainstem and get synthesized into higher level information such as visual images and sounds, thus creating dreams, or so they thought. And here's another article, says it a little more technically, from the American Journal of Psychiatry. The formal features of the generator process with strong implications for dream theory include periodicity and automaticity of forebrain activation, suggesting a pre-programmed neural basis for dream mentation in sleep, intense and sporadic activation of brainstem sensoromotor circuits, including reticular, oculomotor, and vestibular neurons, possibly determining spatiotemporal aspects of dream imagery, and shifts in transmitter ratios, possibly accounting for dream amnesia. The authors suggest that the automatically activated forebrain synthesizes the dream by comparing information generated in specific brainstem circuits with information stored in memory. And again, if you want, you can go here and read more about that. I've had enough technical jargon for the day. Some key things to remember about the activation synthesis model. It makes three key assumptions: that high levels of brain activity in the brainstem are necessary for dreaming to take place, that activation in these areas of the brain results in REM sleep and dreaming, and by corollary, all dreaming takes place during REM sleep, and three, that the forebrain attempts to place meaning on the random signals created from the activation of the brainstem, resulting in what we experience as coherent dreams. Here is a picture that kind of does a little more to explain it. I'm not going to read this whole thing, but I do encourage you to just at least give it a look, because they had a whole theory worked out for how this works. And that brings us to the idea of, are dreams meaningless or motivated? And this is still an open question in dream research. So just to kind of summarize that dichotomy or contention. There are two widely held views about dreams. One is that they contain information about our waking life, including our waking cognition and emotions, and possibly even some information that we have been motivated to ignore or suppress while awake. On this view, dreams are worth examining. In the other view, dreaming is a delirium. Dreams are senseless. Any information in them is likely to be misleading, having little connection to reality. On this view, dreams are best ignored. These two views are each widely held in the lay population as well as amongst psychologists. So there are definitely, to this day, a lot of people who think, bah, horse pucky, and a lot of people who think, whoa, very important. I happen to be one of those. Back to the article. Hobson went on to say the dreams were generated by random activation of the forebrain. Then we have this gentleman, Mark Solms, who is a professor of neuropsychology at the University of Cape Town. And I think I have just a little picture of him here. You can see I think he's still teaching to this day. As we get closer and closer, a lot of these researchers are still alive. Solms was originally trained as a neuroscientist, but began studying dreams and later trained as a psychoanalyst. So he became, I have my note here. I don't want to say this wrong. I'm definitely going to say it wrong. A neuropsychoanalyst, focusing on the neurology of the brain as it relates to psychoanalysis. Solms said that, you see things in dreams because your visual cortex is excited. You hear things because the auditory cortex is excited. The forebrain connects all the images together in a futile attempt to make a story or an episode out of what's happening. The narrative, he says, doesn't mean anything. Hobson's activation synthesis theory remained the accepted explanation for how many dreams are generated, and Freud's ideas were thus being discounted by mainstream scientists around the 1970s. That is, until Solms made a discovery that had to do with lesions on the pons at the brainstem in people who were still having dreams. So just to kind of summarize this, if the pons is where random neurons are fired, what happens if that's damaged? He found out even if the pons is damaged and it's not firing like in a way consistent with other people without damage, that people are still getting dreams, and that's why we see some additional questions being added. Solms says here he was taken aback. We know that damage to this structure leads to a loss of REM sleep, and therefore, he said, it must lead to a loss of dreaming. But it did not. And this is what led Solms to publish this paper here, available at the National Institutes of Health. Dreaming and REM sleep are actually controlled by different brain mechanisms. He says a mounting body of evidence suggests that dreaming and REM sleep are dissociable states, and that dreaming is controlled by forebrain mechanisms. Recent neuropsychological, radiological, and pharmacological findings suggests that the cholinergic brainstem mechanisms that control REM state can only generate the psychological phenomenon of dreaming through the mediation of a second, probably dopaminergic forebrain mechanism. And back to the article here. The answer came, let's see, he says, I was taken aback. He had disassociated REM sleep from dreams, but it left the question wide open once more. What part of the brain then is causing dreams? The answer came as another surprise. There were brain structures which, when damaged, led to the cessation of dreaming. One was the part of the brain that processes spatial cognition. But more interesting was the fact that dreaming also stopped with damage to the part of the brain that controlled motivation. Patients who have suffered damage to this part of the brain, the ventromesial quadrant of the frontal lobe, not only lose their ability to dream, but have a complete lack of motivation to do anything. Patients basically do nothing of their own volition, says Solms. They can perform any action, no matter how complex, so long as you instruct them to do it. They don't have any internal drive to initiate that behavior on their own. The research showed the dreams were not controlled by the basic automatic mechanisms as had been thought, and the fact that the particular aspects of the mind that seemed to be the most critical for generating dreams was the motivational mechanism. And that was particularly interesting. It was very close to the sort of conclusions that psychoanalysts were drawing from Freud's work. Strong though the evidence was, Solms cautioned against any rash conclusions. He said, "This is not proof that Freudian dream theory is necessarily correct," but he does say it makes Freudian dream theory neuroscientifically possible and even plausible. All we can say is that dreams are generated by higher brain mechanisms. So again, it's removing the idea that all of this is happening in our kind of lizard brain stem, and it's actually happening in the frontal cortex areas that control a lot of other more conscious functions. And where were we here? I think I might have briefly lost my place. So now, finally, we come back to Domhoff. And Domhoff, however, says that both activation synthesis theory and Solms' updates of Freudian theory do not explain everything. Freud, he points out, argued that the wish fulfillment aspect of dreaming should be most prominent in children. This is impossible on the basis of experiments carried out in the late 1990s. There's good research that suggests children only gradually develop the capability of dreaming. Children under the age of 6 or 7 do not dream very often or very well, and children do not have adult-like dreaming until at least the age of 10. Studies of the dreams of college students all over the world also reveal more similarities than differences. The dreams collected in the 1950s don't differ that much from dreams collected in the 1990s. They tend to be about personal concerns over family or significant others. Any pattern would indicate that the activation of the brain might not be random. Certainly, that's not something the Freudians or the activation synthesists would have anticipated. I think I jumped ahead too far here. And here we have Domhoff's own cognitive theory of dreaming, developed after studying thousands of dream reports over several decades, suggests that the brain could be actively creating dreams in the same way it creates waking thoughts. And just briefly, I want to pop over here. Oh, session timeout. Okay, and yeah, I was going to reload the page. It took me too long to get back there. Oh, well, son of a gun. There we go. All right, this is the page I was looking for. And this is the article from 2001, which was written by G. William Domhoff, and he proposes a new neurocognitive theory of dreams. And I lost the information I was going to share with you here, but you can go here. And this was one of his more important contributions, and I think it should be read. But quickly back to the article. Domhoff says, the brain's goal is always to construct a reasonable image of the world based on the material it's receiving. If you're in a situation where it's not receiving any information from the outside, then it starts to invent. A cognitive theory says that dreaming is just a form of thinking with some subtle changes. It is because the brain is trying to construct a reasonable picture of the world with the information that it has. But what is the point of all this activity? Revonsuo, I'm not going to try and say that again. A researcher at the University of Turku's Center for Cognitive Neuroscience in Finland says that dreams do serve a function. If we look at the dream research literature, where thousands and thousands of dream reports have been systematically analyzed for their content, there are certain features that stand out, he says. The various negative elements seem to be more prominent than the corresponding positive elements. Negative emotions are more common than positive emotions, and aggressive interactions are more common than friendly interactions. Revonsuo will argue the case for his threat simulation theory next week, which this article was written a while back, so he's already done that. And he did so at a Study of Dreams annual conference in Copenhagen. What do we got here? About 80% of people have had dreams where they are being attacked or chased. Revonsuo explains the negative dreams as a sort of simulation for real life. He says, we know the environment in which our ancestors lived was full of all sorts of threats. The function of these dreams is to be simulations of the most dangerous threat in that environment. His theory also takes in why we might have recurrent nightmares. He says dreaming gets stuck or starts to repeat its most horrible experiences just because that is exactly the function of dreaming, in his opinion. He says it is to identify the most dangerous situations where we have ever been during our lives. And some other psychologists have mentioned this lately, that we have the ability to play out logically and enact a simulation in our mind of, what if I do this thing? What are the challenges I might face? What are the complications? What strategies might I use? And this basic theory here is saying, while you are asleep, your brain continues to do that systems analysis function of what threats are in my environment, how do I handle them, and then we can hopefully come to better decisions about or clarify our perspective, try to come to a better understanding of what it is we face, how we feel about it, what we want to do about it. And I think that's very significant. And certainly in my dream work, I'm looking at these, and not everything is a threat. Some things are wishes, but it's also it's fears. What do you want, or what do you not want? And that motivational aspect of it guides a lot of my work, looking for that motivation. Where is it? What does it mean? And so forth. If his theory is correct, then nightmares could simply be a way we are all designed to dream. But theories such as his will need more experimental evidence if they are ever going to be accepted fully. Solms, as of the writing of this article, was about to embark on a project that would use functional magnetic resonance imaging to study the brains of people who are at the onset of sleep. He wants to use the experiment to test more of Freud's theories. If the function of dreaming is to protect sleep, which is what Freud hypothesized, the patients who don't dream should have a more disturbed sleep. If the function of dreams is to consolidate memory, which is another highly influential theory, then you should be able to determine an inferior learning curve in patients who are unable to dream from those who are able to dream. Solms argues that dreams are a key to bringing psychoanalysis, effectively the study of the subjective experience of the brain, closer to neuroscience, the objective and more scientific counterpart. Dreams played such an important part in the development of psychoanalytical theory, which for all its faults was at least a serious attempt to grapple with that aspect of the mind that neurosciences had tended to, hey, don't eat my cord. You can be cute over there, but you leave my mouse alone. Oh, you little shit. That's enough. That's enough. No more cat interruptions. And back to Domhoff. He argues that understanding dreams will fulfill an even more basic requirement for scientists. Domhoff says if you're going to have a complete theory of the mind, it's got to have the range to encompass dreaming. And at this point, it's a good time to say, well, what exactly did Domhoff do, and why is he important? So what he has done is to build a bank for dreams. And get off the cord. Cats, gotta love them. To folks like Domhoff, serious researchers, dreams are a numbers game, and you're going to prefer to work with big data sets, not single or discrete instances. Over the years, Domhoff has collected and analyzed a vast library of dreams and is one of the founders of the Dream Bank, an online archive of over 22,000 dreams. The database, which is available to the public, is an attempt to quantify one of the most ephemeral of human experiences. And I've got the website here. It is simply www.dreambank.net. And this is still up. You can look for it today. You can search dreams, and I believe you can still contribute. So I wanted to make sure you guys saw that there. So what do you get when you have large data sets? You start to recognize patterns. And that's one thing they did here. This pattern recognition in dreams. So some of the conclusions drawn or by Domhoff or about his researchers or about his research. Excuse me. It says here, until researchers have gathered many more high-quality reports from a wide variety of people, ideally accompanied by multiple sources of biographical data, we cannot make any definitive declarations about the universal features of human dreaming. But the results of this study suggest several testable hypotheses. Number one, dreaming perception is primarily visual, with less hearing and touch and almost no smell or taste. I have found this to be true in talking to many people. Number 2, all emotions are represented in dreams, with fear being the most frequent. And as I would put it, it's the fear of something not happening because you want it to, or the fear of something happening because you don't want it to. It's that, enough said about that. Number 3, many types of cognitive activity occur in dreaming, especially those associated with awareness and social intelligence. Number 4, aggression is more frequent than sexuality, and both are more frequent for men than for women. And here's another great page. Again, links will be in the comments below. This was is a website called Insomnium, and it talks about the quantitative approach to dreams. And this was something Domhoff partnered with a fellow named Schneider on. I did not bring up a picture of that guy. Domhoff advises that 100 to 120 dream reports in each sample are necessary for any findings to be reliable. And this means what he did was he said you can't just get a complete picture of a person from, say, one dream. If you're going to be doing a personality or psychological profile of someone and trying to give them as much useful information about themselves as accurately as possible, he says you want a minimum of 100 to 120 dreams to analyze. But once you've done that, you can formulate or you can subject those dreams to a 4-step content analysis. Now, my process is a little bit different. It's unique. Of course, everyone does. And I'm not by any means the most experienced or accomplished expert, nor do I think my theories are the only way to approach these things. But back to the article here. He says you can formulate, number 1, you formulate categories for all the elements that appear in dreams. For example, there are characters, there are activities, there are emotions, and there are social interactions. And I do a little bit all of these things intuitively more than methodically, so to speak. Like I don't have a form I fill up. Maybe someday I will. Maybe I should give this a try and see what happens. Number 2, you count the number of times that various elements appear, how many male characters, how many female. I don't know personally that has a lot of relevance in counting instances. I mean, you can do that, and it does yield data. My approach, of course, is different. Number 3, he says here you turn the frequencies of categories into percentages and ratios. For example, the animal percent would be the total number of animals appearing in the dream divided by the total number of all characters in the dream. Or, for example, B, that the male and female percent. What percent of dreams have at least one of something, one instance of aggression, and the something calls the FC index, the number of friendly interactions divided by the total number of characters. And number 4, you compare these findings in the 3rd section with other norms. So long story short on this one, whatever his method is, he's trying to come up with a method for getting a more statistical, measurable, something you can put down on paper and look at. You can graph it, you can chart it. I think it's a worthy exercise, and I would not presume to tell a person who spent his life's work coming to this point of attempting to apply quantifying metrics to dreams. I go in a different direction. So, but then again, I may take a second look at this and try to incorporate a little bit more of this. Maybe there's something there that I'm missing, and there's always a chance to grow. At this point, I think you're a little more familiar with how we got from Freud and Jung to modern research. There's more of this data to assimilate and share with you. But the big part is to say, what came in between and where are we now? And this is where we're at right now. I do want to point you at some of Domhoff's works. We've got this one here. I think this one was his oldest book, and he wrote Finding Meaning in Dreams, Emotions, Personality, and Psychotherapy. He also wrote this one, The Scientific Study of Dreams, Neural Networks, Cognitive Development, and Content Analysis. And I believe this is his most recent book from 2018, The Emergence of Dreaming, Mind Wandering, Embodied Simulation, and the default network. And I'll just pop us back up here because this is the end of another episode of Augury, Bibliomancy and Chaos, your ABCs of dream interpretation. For more information and for your personal edification, I will be gathering again these links down in the comment section below. If you like my content, please like, share, subscribe, and but above all, thanks for listening.